Today we are going to discuss the topic about synchronous condenser. An overexcited synchronous motor running on no load is known as synchronous capacitor or synchronous condenser. A synchronous motor takes a leading current when overexcited and therefore becomes a capacitor. When such machine is connected in parallel with the induction motor or other devices that operated lagging power factor, the leading kV are supplied by the synchronous capacitor. The overexcited synchronous motor running at no load, that is called synchronous condenser. The synchronous motor overexcited is taking of leading power factor angle of del. Overexcitation means that back EMF greater than applied voltage, that is called overexcitation. This is the phasor diagram of synchronous motor. Then advantage. By varying the field excitation, the magnitude current drawn by the motor can be changed any amount. This helps to achieving stepless control of power factor. The motor winding have high thermal stability to the short circuit current. And another one advantages is the fault can be removed easily. Disadvantage, there are considerable losses in the motor. The maintenance cost is high. This is the synchronous condenser and phasor diagram. First one is synchronous condenser and another one is phasor diagram of synchronous condenser. V is V phase and current lags to theta. The phase difference of V and I is called theta. Now hunting. Hunting means that a synchronous motor is used for driving varying load. Then condition known as hunting is produced. It also caused by supply frequency pulsating. When the synchronous motor is loaded, its rotor falls back in phase by coupling the angle of del. Load increases, this angle also increases, so that produce more torque to carry the increasing of load. If sudden decreases in load, motor immediately pulled out or advanced a new value of del. Motor overshoot the, hence it's again full back. Minimize the effect of hunting is to increase the moment of inertia of rotating system by putting a flywheel. Causes of hunting: sudden change in load and sudden change in field current, a containing harmonic torque, fault in system. Effect of hunting. The effect of hunting of synchronous motor is lead to loss synchronism and produces mechanical stresses. Increase machine losses cause temperature rise and greater surges current and power flow. This is the hunting in synchronous motor diagram. Reduction of hunting in synchronous motor. First one is use chamber winding. It consists of low electrical resistance made up of copper and aluminum braced embedded in slot fold base salient fold machine. Damper winding damps out hunting by the producing torque opposite to slip of rotor. The magnitude of damping torque is proportional to the slip speed. Use of flywheel. The prime mover provided to large and heavy flywheel. This increases the inertia of prime mover and helps the maintaining the rotor speed constant. Designing synchronous machine with suitable synchronizing power coefficient. Merits. It runs at constant speed. The only way to change speed to vary the supply frequency because n is equal to 120 f divided by p, and it not currently self-starting. It can be operated under wide range of power factor, both lagging and leading power factor. Most of the synchronous motor rated between 150 kilowatts and 15 kilowatts and speed from 150 to 1800 rpm. It less costly. Demerits. First one is not self-starting of the machine. Then needs frequent maintenance and external DC supplies given to the rotor circuit. Additional damper winding is necessary, and hunting effect is very large problem of the synchronous motor. Thank you.